Okay. So the we have studied the synchronization mechanism in our last class. We saw two different methods. One is log variables and another is TSL. TSL. Yeah. And also we saw some properties as well, TSL as well as and for log variables. Okay. Also we know that TSL is it is a special type command. So some of hardware or computer may not support this TSL technology. Okay, so it is called this platform dependent. Okay, also um, both the algorithms you can implement in user mode as well as TSL algorithms and also local algorithm. Both are the busy waiting solution. They are busy waiting solutions. You know that it's when it executes when you schedule some another process, it's always executes one while loop, okay, unnecessary while loop, okay. So it keeps the CPU busy. Okay, also to evaluate a synchronization mechanisms, we apply three methods. One is the mutual exclusion, another is progress, another is bounded condition. Okay? Bounded waiting. Okay, so if a algorithm satisfy all of these three properties, then we can say that this is the good synchronization mechanism. Okay. Already we have seen that log variable actually doesn't suffer mutual exclusion. This is the actually major properties for mutual synchronization mechanisms. Also, TSL doesn't grant the bounded waiting. Okay, this kind of some drawbacks as well as the benefit of different algorithms or mechanism, synchronization mechanism. Also, so far we learned the log variable as and the TSL mechanisms, and today we'll try to learn. Okay, we'll learn three more algorithms. First one is strict alternation method. Alternation method. Before we study, let me share my screen. Okay. Okay, so today we learn two more. First, we learn the strict alternation methods. Okay, strict alternation methods. Let me write it here. Write down here. Strict alternation methods. Okay, this is the algorithms. Strict alternation methods. Today we learn. Also, log variable as well as the TSL. Both are multi-process solution. Multi-process solution means that this these algorithms or this TSL and as well as the log variable, you can apply more than one process. Okay, more than one process. But strict alternation method, you will apply only for you can apply only for two process. This is two process method. Okay, strict alternation method is a two process method, not a multi-process solution. Okay. Okay, this is just to gives a heads up that strict alternation is two process method. It doesn't support the multi-process uh, systems. Okay, like log variable and TSL. Okay. Okay, let's see how you can implement the strict alternation methods. Okay. To implement this strict alternation methods, you need to maintain one variables, one Boolean type variables. It's called the turn variables. Okay, turn variable. It's a Boolean type variables. Okay, Boolean types variables. It takes only value between 0 and 1. Okay, 0 or 1. Okay, so let's see how it works, and then same as it has the anti-section code. Anti-section code is how it's implemented anti-section codes, while turn value can be it maintain one value. We can say this is kind of global type variables. Both process can update this value. It is turn, while turn equals 0 or 1. Initially, let's say it is 0, turn is 0, turn is 0. So first process, let's say this is process P1. Process P1. It also I mentioned that you can apply for this two process system. Let's say turn. At first, it will check this turn equal 1 or not. If it is 1, then it will actually go through this process P1 will be executes this while loop. Otherwise, it will enter the critical section, and when it's exit section, it will make this turn equal 1 as well. Okay, turn equal 1 as well, and this is the code for P1 by using this turn variable. And what is the another process? Let's say process P2. What is the code for this process P2? While it will check this turn value is either 0 or 0. It will check this turn value 0. Then if it is 0, then it will actually look through this while it will execute only this while loop. Otherwise, it will enter the critical section and makes this turn value when this the exit section code. Exit section code. It will here turn value will be the 0. Okay, this is the code for process P1, P2. This is for process P1. Okay, so here is one turn variable actually they use, and they just change this turn value. Okay, this is two process solution. And then let's check how it works. Okay, there is turn. Let's say initially turn value is 0. Let's say initially turn value is 0. Let's check this turn value is 0. So how it's work? Let's say process P1 shows your operating systems execute the process P1, and process P1 will execute. It will check this turn value, turn equal 0 1. If turn equal 1 but turn equal 0, it is fine. So it will skip this while loop, and then it will enter the critical section inside this critical section. Okay, and it will execute its critical section. Once it is done, it will make this turn value as a 1. Turn value 1. So it will make this turn value 1 instead of 0. It will make this turn value 1. What does it mean? If it is make this turn value 0, then what's happened? Again it can enter this critical section. Turn value 0 means that again I want to enter this critical section. Here turn value is 1 means that okay, I complete my critical section. Then next process, he allows this next process. Okay, this is your turn. Now you can execute your critical section. Okay, this is how actually here once P1 done its execution, it actually makes this turn value is 1. Okay, turn value is 1. Actually, it gives the opportunity another process P2 for entering the critical section. Okay, for entering the critical section. Okay, now turn value is 1. Now let's say your operating system schedule the process P2. What's it will check? It will check this turn equal 0. No, turn equal now currently 1. So it will skip this while loop, infinite while loop, and then not infinite while loop. Actually, this is while loop, and then it will enter the critical section P2. P2 will be enter this critical section, and again it is done. It will make this turn value as 0. Okay, 0. Now turn value is 0. Again it becomes 0. Now what does 0 means? 0 means that P2 actually gives the signal that okay, I complete my complete the execution of critical section. Now your turn P1, you can complete your critical section. It is like this. It is like this. This way it works. Okay, this is how it works. Now let's check this our three properties like mutual exclusion. Does it granted or not? Okay, mutual exclusion. Okay, first property is mutual exclusion. It supports or not. Okay, what does what is a mutual exclusion? If a process inside this critical section, that another process cannot be inside this critical section, means that two at a single time at a time point, two process cannot be entered this critical section. Okay, only one process should be inside this critical section. Okay, this is mutual exclusion. Okay, let's check this mutual exclusion granted or not. Okay, here you see this is only when the turn value is 1. When turn value is 1, this time only the process P1 can enter this critical section. When turn value is 0, this time only process P2 can enter this critical section. Okay, so this is only single variable and two process. So there is no chance. There is no chance two process can be entered this critical section. Okay, this is two different value. One is 0 if it is single variable, Boolean variable. If it is 1, then P1 will be inside this critical section. If it is 0, then P2 will be inside this critical section. Here actually you and inside between you didn't change any turn value. Okay, so if it is turn value is, let's say if it is at first turn value is 0, so here it will executes P1 is executes this while loop, and it will skip this while loop, and it will be enter this critical section. Okay, now P1 enter this critical section, but turn value is 0. Turn value is 0. Okay, now let's check this. P1 is inside this critical section, and your operating system again schedule the process P2. Let's check process P2 can be enter this critical section or not. Okay, here P2, and then while turn equals 0. Now turn equals 0. So your process P2 will execute only this line. Okay, because turn value is 0. And it means that process P1 is already inside this critical section. So there is no chance the process P2 enter this critical section. Okay, so at a given time, there is only one process can be inside this critical section. Okay, so it's granted a mutual exclusion. Okay, mutual exclusion is satisfied by this turn value. Okay, mutual exclusion is satisfied by this turn variables. Okay, now let's check another process. Another properties is progress. Okay, progress. What does progress means? Progress is nothing but if a process is not inside this critical section, then it should not stop to enter another process for entering the critical section. Okay, if a process is execute the non-critical section, it shouldn't stop this another process for entering the critical section. This is the progress. Okay, let's check this progress is satisfied or not by these algorithms. Okay, let's see this process P1 is first scheduled by your operating system. It executes and makes this turn value. After executes, and initially turn value is of course 0. Initially turn value is 0, and your process your operating system is scheduled the process P1. Process P1 is scheduled by the operating system. So what it will do, it will execute this while loop, and a while loop will be skipped because turn value is 0. Here is turn value is 1, check by turn value is 1, so it is skipped, and it will be inside this critical section. And let's check your P1 completes the critical section and makes this turn value as 1. Okay, 1. Turn value is 1. Okay, turn value is 1, and then it's going back. It completes this critical section, and then next your operating system is scheduled the process P2. Process P2. Your operating system is scheduled the process P2. Let's check. Let's consider this. This is critical section. No? Okay, this is critical section. So beside this critical section, there would be some non-critical section. Okay, non-critical section in here. Also non-critical section after this here turn value. Also here is same. Before here is can be non-critical section. Of course, non-critical section here. Some non-critical section code as well. Okay. So now your operating system is scheduled the process P2. Let's say process P2 is now executing the non-critical section. And in this region, P2 got the preemption, and P1 is scheduled. Okay, P1 your process P2 is currently executing the non-critical section. It is not even entering the critical section. It is currently executing the non-critical section of code. There's 1,000 lines of code. It's a big process. Of course, over 1,000 lines of code can be available. Okay, more than 1,000 lines of code. And in this point, let's say your P2 process P2 preempted by the CPU. Okay, now again process P1 is scheduled by your operating systems. So P1 is completes its non-critical section. Let's say completes non-critical section. and it's trying to enter this critical section. Okay, here you see turn value is 1. Turn value is 1. So here is turn value is 1. So process P1 will execute this while loop. Okay, currently you see this P1, no process inside this critical section. Your P2 is executing the non-critical section code, and P1 is executing the non-critical section. After complete the non-critical section, he's interested to entering the critical section. But uh, due to the process P2 is not entering the critical section, that's why it is blocking here. No process enter this critical section, but still another process cannot enter this critical section. P2 is executing the non-critical section, but P1 is still blocking here. Okay, so yeah, from here you can see process P2 executing the non-critical section, and no process is currently enter the critical section, but still P1 cannot be able to enter this critical section. Okay, enter this critical section because here is only P2's P2 completes its critical section, then it will make this turn value is 0, and then P1 can executes the critical section. Okay, so progress is not guaranteed by this strict alternation methods. Okay, no process enter this critical section, but still it's block another process for entering the critical section. Okay, this is progress is not satisfied in here. Let's see that bounded waiting is satisfied or not. Okay, bounded waiting, another thing. So okay, bounded waiting, another properties. Okay, 3 properties. So mutual exclusion is satisfied. Let's say bounded waiting is satisfied or not. Okay, bounded waiting means that one process completes its critical section, and then another process actually shows the interest for entering the critical section. And in this case, the another process cannot actually execute the critical section again and again by waiting the another process. Actually, whose process actually shows the interest for entering the critical section. Let's say here is two process. Process P1 is currently executing the critical section, and by this time, process P2 also shows its interest for entering the critical sections. And let's check this process P1 can again enter the critical sections by waiting the process P2 or not. Okay, if process P1 again enter this critical section by waiting the process P2, even the process P2 shows interest for entering the critical sections, that time we can say this bounded waiting is not guaranteed. Okay, bounded waiting is not guaranteed. Okay, let's check this how we can prove these things. Okay, let me clear some part. Okay, process P1, here is okay, process P1. Okay, this is process P2, here is 0, so turn. Okay, here is, let's see here. Okay, here is turn is 1. So for checking this bounded waiting, we have to make a one while loop over this two process, infinite while loop. Okay, and then okay, this is for infinite while loop for two process. Okay, infinite while loop. Okay, now let's see this your operating system first actually schedule the process P1. So process P1 what, and turn value is initially 0. Turn value is 0. Let's check turn value is 0 in here. Okay, your operating system schedule the process P1 and turn value is 0. That while then turn value is here, it will check this turn value is now currently 1. So it will skip this while loop, and then it will enter this critical section. Okay, P1. Okay, P1. Then process P1 is now currently executing the critical section, and P1 got printed here, and P2 is scheduled by this operating system. And P2, what P2 will do? P2 will see that turn value is 0. Turn value is 0, and it will execute this code. Okay, this code again and again until it's actually its schedule time is finished. Finished. Okay, so it will execute this while loop because turn value is 0, because P1 entered the critical section. Okay, now let's check this. P1 completes this critical section, and again it can enter this critical section or not. If it is again enter this critical section, then bounded waiting is not granted, because it's actually makes wait for process P2 for a indefinite number of time. If it is again can enter this critical section. Okay. Okay. Also, you know that P2 already shows is interest for entering this critical section. Okay. So now P1 inside this critical section and completes its critical section, and then makes this turn value is 1. Turn value is 1 in here. Okay. This is exit section code. Okay. This is exit section, and this is enter section and entry section of code. Okay. Entry section of code. This is exit section of code. Okay. Okay. When it's done, P1 is done, currently done. So P1 is currently executing in here. So P1 is done and make this turn value is 1. Okay, 1. Okay. Let's see that again P1 can enter this critical section or not. Okay. Now let's check again. It will be in here. P1 is scheduled by the operating system while, and then it will see this turn is 1. So turn is 1. Okay, turn is 1. So it will execute this while loop. This while loop. Okay, P1 cannot enter this critical section. Enter this critical section. Enter this critical section because now currently turn value is 1. Currently turn value is 1. It makes this turn value is 1. So it cannot enter this critical section until P2 completes this critical section. Okay. So here bounded waiting is guaranteed. Okay, bounded waiting is guaranteed because P2 actually already shows the interest, and then P1 completes its critical section. Again, it cannot enter this critical section by waiting the process P2. Okay, let's check again. P2 is scheduled by the operating system, and here it will see that turn while turn equals 0. No, turn equal not 0. Turn is currently 1. Turn value is currently 1. So it will enter this. P2 will enter this critical section, and then it will make this turn again 0. It will make this turn value is again 0. Now it is fine. Let's say again P2 can enter this critical section or not. Then again it will be in here. Now it is turn equals 0. So it will execute this while loop. So it cannot enter this critical section again. Okay. Again. So now P1 can enter this critical section. Okay. So one process cannot make the wait for a long time or wait for an indefinite time for executing the critical section. Okay. So bounded waiting is guaranteed in these algorithms. Okay. In this algorithm. So in here, mutual exclusion is good and bounded waiting is good, but progress doesn't satisfy for in here. Okay. Okay. Any questions or comments so far? Okay. So let's look through some properties for bounded waiting. Similarly, similar as previous algorithms, bounded waiting is also not bounded waiting. Strict alternation method. Strict alternation method is also busy waiting solution because it executes a while loop. Okay, it executes infinite an unnecessary while loop. Okay, so it is busy waiting solutions. Also, another thing is that this is two process solution. You cannot apply for multi process. Okay, this is only one Boolean variable turn value, and you can apply only two process. Okay, not multi process. This is hardware platform independent, means that there is no here you don't use any special type of command like TSL. In previous we use the TSL command, but here you don't apply any special type of command. So it is hardware independent and implemented in user mode. Implemented in user mode means that you don't call any kernel level or kernel level function or system level function. Okay, so you can implement it in user mode or user process. Okay. Okay, these are the some properties for strict alternation methods. Okay, so our next algorithm is interested variables. Next method is interested variables. Okay, interested variables. So it is similar as turn variable. Turn previous method is strict alternation method, but instead of two variables, instead of one Boolean variables, in interested variables, in these methods we use two Boolean variables. In strict alternation methods, we have only one Boolean variables, but in interested variables method, we have two Boolean variables, okay? Two Boolean variables to implement the synchronization mechanism, okay? Okay, two Boolean variables here. It's required for these methods, okay? Okay, so let's check this how it works. Here is two value. One is for, let's say, interested 0 is one variables, one Boolean variables. Its value is also true or false, T or F. Okay. Also another is interested 1. Its value also T or F. Okay, true or false. Okay, these two values is Boolean variables. There is two variables used in this method. Also, it is also a two variable solution, not multi-process solution. Two process solution. Okay, not multi-process solution. So let's see this process 0. Process 0, how you can implement this, and also process 1. This is two process. This is process 1 and process 0. Let's say how it works. Okay. Okay. So in here, let's say there is at first non-critical section, and then what's it will do? Interested 0 makes the T, and then I will explain it. Notice, and while interested 1, another value will check this, it is T or not. If it is T, then it is inside this while loop, and then it will enter this critical section, and then what's will do for exit? This is entry section. Okay, this is entry section for this critical section. Okay, critical section. This is entry section. Exit section code is like interested to make this interested 0. Interested 0 equal F. Okay, make it false. Okay, false. And this is the code. And for process 1, it's same. For process 0, use this interested 0. This is its variables, and interested 1. This is process 1 variables. We can say process 1 variables. Okay. And CS, I'll explain this that one. What is the entry level code? It will make this interested 1 as a true, and then it will check this another value while interested 0 equal true or not. If it is true, then it is this while loop. Otherwise, it will be critical section. And what is the exit section code? Exit section, it will make this interested 0, interested 1 as a false. Okay. Interested 1 equal false. Okay. 1 equal false. Okay. 1 equal false. Okay. Okay, so this interested 0 and 1, this is kind of global variable for these two processes. Okay, you can say this way, you can check this way. Okay, so now let's check how it works. Okay, here is two value. Interested 0 is for this process 0, and interested 1 is for process 1. Okay, so what it will do, at first process, if a process try to enter this critical section, it will makes that it will show that I am interested for enter the critical section. Okay, I am interest for entering the critical section, and then next it will check that while this another process interested to the critical section or not. Okay, at first it will check, it will when it's executing the code in the entry section, it will check this. At first it will make this, okay, I am interested for entering the critical section, and then it will check this another process is also interested for entering the critical section or not. If it is interest for critical section, then it will actually it will stop in here for this while loop. Okay, if another process interested for entering the critical section. Okay, if it is actually observed that this another process is not enter the critical section, that what it will do, it will enter this critical section, and then exit section it will makes this. Okay, I am done. I makes my interest as a f. Okay, I am not enter the critical section again. Okay, I'm not enter the critical section again. I'm done. Okay, make it f. Okay, this is interest 0 for this 0 process, and this is 0 process. And while loop is execute this interested one, this variable for this variable for this process variables. Okay, interested one t means that another process p1 is interest for entering the critical section. In that case, it will just execute this while loop. Okay, even though it makes t true at first interest, make it interest, and then it will check this another process interest for enter the critical section or not. If it is, then it will execute the while loops. It will give the chance another process for entering the critical section. Okay, this is how it works. Okay, now let's check this how it works. Let's see that at the beginning no process enter the critical section. All process is f, false, not enter in the critical section. What will do? Process p0, p0 is currently scheduled by the operating system. It will execute the non-critical section and makes this turn interested 0. Interested 0 makes it true. Okay, means that I am 0 process, p0 process. I am interest for entering the critical section. Okay, now it will check this while interest 1 is t. Interest 1 is false currently, so it will skip this while loop and it will be enter this critical section. P0 will be enter this critical section. Okay, if it is done, then it will make this t as an f. Okay, t is an f. Okay, so it can complete this critical section. Okay, now let's check this process p1. Same process p1 can also enter this critical section in this scenario. Let's say process p1 is scheduled by the operating system. It will execute this code and make its interest as an as t, means that I enter the interest for enter the critical section, and then it will exit check this while loop. While interest 0 means that another process is currently enter the interest for entering the critical section or not. Okay, this is interested 0. These variables, this variable is currently false. Okay, so it will skip this while loop, and p1 also will be enter this critical section and complete this critical section part and makes this interested one as an f. So interested one will be f. Okay, so this is how it can complete this critical section. Okay, now let's check this. These variables, this process can complete can actually satisfy or guarantee the mutual exclusion or not. Mutual exclusion means that no at a given time two processes cannot be inside this critical section. Okay, two processes cannot be inside this critical section. Okay, let's check these things. Okay, now let's check this process p1. Sorry, p0 is currently interest for entering this critical section. P0, this process p0. Okay, here is both values f false. No process is now currently interest for entering the critical section. So both value is f. So in here, and then interested 0 will be the t. It means that I am interest for entering the critical section, and then it will check this while loop while another process is interest for entering the critical section or not. Here interested t is f, currently f, so it will skip this while loop and process p0 currently enter the critical section. Okay, and it is currently executing the critical section. And let's check by this time p1 is scheduled by the CPU, and p1 can enter this critical section or not. If it is p1, if in the currently p0 is inside this critical section, if p1 is now enter this critical section, then actually it doesn't satisfy the mutual exclusion, means that two process can be inside this critical section. Okay, now let's check this. By this time, in this situation, now currently p0 is inside this critical section. Okay, and this process got preempted by the CPU, and your operating system executes the process P1. Now let's check this P1 can be enter this critical section or not. Okay, so P1 will be execute this line, and then it will make this interested as a T. As a T means that I am trying to interest for entering the critical section, and then it will check this interested T, interested 0 is T or not. Okay, so interested T is currently T. Okay, interested 0 is currently T, means that it is now interest for entering the critical section, or it is now currently inside this critical section. So it will execute this while loop. Okay, it never enter this critical section. Okay, so no at a given time there is no way two process can be enter the critical section. Okay, so mutual exclusion is satisfied by this algorithms. Okay, now let's check this progress is guaranteed or not. Okay, before we check this progress is guaranteed or not, here there is one thing we need to check in here. Let's look at in here carefully. This is one of the good point, one of the actually biggest point for operating system. Let's check that one. Okay, these algorithms. Okay, here you can see that process. Let's check this process P1 is now executed by the CPU. All are no process is now currently under the schedule. Now we take this progress thing. Okay, all that process P0 is P0 is scheduled by the CPU, so it execute the non-critical section and make this interest 0 as a T, and then after this T, after this interest in ET in this line, it got preempted. Here it got preempted. Okay, P1 makes this, P0 makes the process interested as 0 as a T. Okay, now let's check this. P1 got the CPU. Also, process P1 execute the non-critical section, and after making this interested as a T, also it got the preempted by the CPU. In here, it got the preempted by the CPU. Okay, CPU. Okay, so P0 and P1 both are, and again P0 is scheduled by the CPU. Now both process is interest for entering the critical section. Okay, entering the critical section, because it is preempted by after executing this line. Okay, interested 0 line, and also here interested 1 line. Okay, in this line it got preempted these 2 lines in here and in here. So it makes this two interested variable as a T. Now again P0 got the CPU. So what it will do? It will see that this interested T is T. So it will execute this line. And again P1 got the CPU. So again P will check this interested 0 is T or not. Okay, it is T. So again it will execute this while loop. Okay, so this is two process system. So now if you execute, if you execute the process P0, so it will check this interested 1 is T. Again, if you execute the process P1, it will check this interested 0 is also T. Okay, so it will only execute this while loop. Actually, what does it mean? Here, two process is now interest for entering the critical section. Interested into the critical section. So process P0 tells that okay, you are interested to the critical section, so you can complete your critical section first. It will actually gives the signal to the process P1. Okay, you are interested. P0 actually check this while loop, and it check this. Okay, interested 1 is T, means that process P1 interest for this critical section. Okay, it is fine. And P0 actually said that okay, process P1 you can complete your critical section, and then process P1 schedule trying to complete this critical section. It will check this while loop. It check this. Okay, interested 0 means that process P0 is interested for entering this critical section. So it will give the request back to process P0. Okay, this is your turn. Okay, you are interested, process P0, you are interested for entering this critical section. So you can go fast. Okay, you can enter this critical section. Okay, so this is a circular waiting. Okay, this circular waiting. Now no process cannot enter this critical section. Okay, this process waiting for this process, and this process waiting for this process. P0 waiting for P1, P1 waiting for P0. Okay, this is circular waiting. Actually, this is known as the deadlock. Okay, deadlock problems. Okay, deadlock. Okay, circular waiting or deadlock. Okay, this is actually referred as the deadlock. Now let's see if it is deadlock problems is in any synchronization mechanism. So progress not never satisfy. Okay, to process in a deadlock. So progress will not be satisfied. Okay, no process enters this critical section, but it is all process. There is circular waiting. Okay, circular waiting, or it is kind of deadlock. So progress is not satisfying here. Okay. Now let's check this bounded waiting is satisfied or not. Okay, bounded waiting. It is called this bounded waiting. Okay, bounded waiting. Let's check to complete this. Check this bounded waiting. We need to make one infinite while loop from two process. Okay, while loop from these two process. Also here we need to add another while loop. Okay, in while loop. Okay. Okay. This is interested 0. This is interested. Okay. Okay. Now let's check this. Process P1, P0 is scheduled by the CPU. Okay, CPU. Process P0 is scheduled by the CPU. So it will execute this while loop and the non-critical section, and then it will complete at first at the beginning. Both processes F, both are F, not interest for entering this critical section. So in this intersection, what's it will do? It will make this interested as a T, interested 0 as a T, so it will be the T, and then while so it is F, so process P0 is happily enter the critical section. Okay. Now let's check this process P0 is enter this critical section at first, and then process P1 is scheduled by the operating system. What process P1 will do? Process P1 enter this non-critical section, make its interest as a T in here, and then interested 0 is T. Interested 0 is T, so it will executes the while loop in here. Okay, it never enter this critical section. Process P1 will be it will execute the while loop. Okay, this while loop. Okay, but it shows its interest. Okay, interest. Okay. Now let's check again. Process P0 is scheduled by the operating system. It is currently under this critical section. So what it will do? It will outs, and then it will make this interest 0 as an F. So this is make it 0 and F. Okay. Let's check again. P0 can enter this critical section or not. Okay. It here P1 is already shows is interest for entering this critical section. Now again P0 can enter this critical section, makes the P1 waiting, means that if it is happen, then bounded waiting is not guaranteed. Okay, let's check this again. P0 can enter this critical section or not. Okay, now again it backs in here, and this is infinite while loop. Let's see, it will execute this non-critical section code first and make its interest as a T, interest 0 as a T. So it makes, when it's out, it makes it F, so it makes it F to T. Okay, T. Now while interested 1 equal T, while interest 1 equal T, currently it makes this interest 1 equal T, so it will execute this while loop. Okay, it will execute this while loop. Oh, okay, so there is no way it will enter this critical section again by waiting the process P1. Okay, because process P1 already shows this interest. Okay, for entering this critical section. Okay, so until executing the critical section of process P1, P0 again cannot be enter this critical section. Okay, so bounded waiting is satisfied by this process. Okay, so here mutual exclusion is satisfied, bounded waiting is satisfied, but progress it doesn't satisfy in these algorithms. Another important major drawbacks in these algorithms, it is suffered by the deadlock or circular waiting. Okay, same as the other process, this interested variable is also busy waiting solution. It is two process solutions. Also, no, it is hardware platform independent. You don't require any special command for these algorithms. Okay. So this is the interested variables algorithms. Let's check another variables is called this Peterson method. Okay, Peterson method is the best method for two variables and busy solution. Okay, Peterson method. Okay. Peterson method is the best solution for two process solutions and busy waiting solution. Okay. Peterson method actually combination of strict alternation method. To do learn, one is strict alternation method. It's one variable. Strict alternation methods, strict alternation methods, and also interested variable. These two methods. Okay, interested variables. Interested. It is combination of these two methods. Okay, Peterson methods. Let's see how it works. It is two process solution P0. Here is it makes a one entry function, entry section function. Okay, entry section, one function call for entry section, and there is a critical section, and also here is one exit section as well. Okay, exit section. Both are these two function. Okay, two function. When P0 is called, is parameter. Parameter is the process number 0. And for when P1, for this process P1, empty section, when it's called this empty section function, it will call at this parameter is process number 1. Okay, process number 1, and then CS, and then exit section. Okay, exit section also another function. Exit section is also another function. Its parameter also the process number. Okay, process number. Okay, these are the two function. Instead of writing the line empty section or exit section, here actually it calls a function to function. Okay, by sending a parameters as a process number as a parameters. Okay, now let's check this check that how empty section and exit section works. Okay, function, what is the empty section function and exit section function? Okay, let's check this one. Okay, void, let me check in here. Void entry section. Void entry section is one parameter is called this integer process number. Okay, process. Okay, what the process is. Okay, and then what it will do, it will make this integer other. What is the other process? Other process is nothing but this is also two process solution, one minus process. Okay, process, how it's referred as it is other process. When it is called when this empty section is called from this process number 0, then other process will be 1 minus 0 is 1 is other process. Okay, this is two process solution. When empty section is called from this process number 1, that means this process value is 1, so other process will be the 0 number process. Okay, so you see this 1 minus 1 will be the 0. Okay, this is the reference this other process. What is the other process? Okay, 1 minus process is referred as this other process. Okay, I think you got it in here. Okay, and the other means that 1 minus process is kind of other process. Here is process 0, either 0 number process or 1 number process. And that is when it is parameter is 1, then other process will be the 0. When parameter is 0, then other process will be 1. Okay, then it will check this interested. This is, we can say this is the global variables or global type array. Interested 0 or interested process. Interested process as a parameters. These parameters. Okay, process make is t. Okay, whatever this call, and then one is turn variable. Turn will be the process. Turn will be the process, and then it will check this while interested other. It will check this other process is interested for entering the critical section or not. And operation, here is and operation, and then turn equal, if turn equal process, turn equal process, then it is actually execute this while loop. Otherwise actually nothing but it is a critical section. Okay, critical section. I showed you this. First is this is empty section code, and what is the exit section code? Void exit section is nothing but integer process, and it will make this interested and interested process equal false. Okay, so whatever this process is currently called this, it make it false inside this exit section. Means that I complete my critical section, so I'm not interested for entering the critical section again. Okay, interested 0, it will be the kind of depends on this process this parameter, it will be the interested 0 or interested 1. Okay, interested 1, there is two process solution. Okay, 0 or 1. Okay, now let's check this how it works. Okay, fine. At the beginning, no process interest for entering this critical section, both are F. Okay, both are F. No process interest for entering the critical section. So if it is, then if no process enters the critical section, then what will be happen? Okay, it will make this, of course it will make this turn value as a 0. Turn value will be the if it is from this process P0, so turn value will be the 0. And then while interest other is F, when at the beginning no process enters this critical section, so those both value is F. So in this case, you don't require to check even this this condition. Okay, this and condition. So one is fail, then this will be the fail. So it will break this while loop and it will be enter this critical section. Any process can be entered this critical section. When it is done, if it is process done, complete this critical section, and again it will make it process. If it is process 0, at first it will make this process here in this line, it will make this process as a T, and then after this done, it will make it interested as an F. Okay, like an interested variables. Okay, now let's check this. If it is 1, same thing is 1, it will check if no process enters the critical section, other process is 0, so other is 0. It will check this other process is interested, 0 is interested in this critical section or not. If at the beginning no process enters the critical section, so it is fail. So it will process P2 also can enter this critical section. Okay, now check this. Does it satisfy the mutual exclusion or not? Okay, mutual exclusion or not means that one process already enter this critical section, and can another process can be enter this critical section or not? Okay, let's check at the beginning. Both these value is F. Okay, this value is F. Interested 0 is also F. Interested 1 is also F. Okay, false means that no process interest for entering the critical section. Let's say process P0 is called by scheduled by the operating system, and it calls this function. Process parameter will be it is process P0, so it will be the 0, and then interested other will be the 1, other value will be the 1, and then interested make it interested process as a true. So this is 0, it will make this process as a T, and then it will make this turn value. Turn is also global value. Turn will make it the 0. Okay, turn is making 0 because process number is 0. And while interested other, it will check this other means that interested 1. This one interested 1 is T or not. Okay, so interested other is F. So you don't require to check even turn value as well. Okay, so it is false. So process P0 is now currently enter this critical section. Okay, now let's check this. In this situation, process P1 can enter this critical section or not. If process P1 enter this critical section, means that it breaks the mutual exclusion. Okay, let's check this process P1 is scheduled by the operating system. So what is the process number in here? Process will be the 1. So other process will be 1 minus 1 is 0. So interested process process means the interested 1 is T. So interested 1 will be the make this T. I just make it reverse. Okay, this is the interested 1. Okay, I just make it due to the in this in here we don't have the space. That's why I make right in left side. Okay, left side. Okay, so interested 1 make it T in this line. Okay, and then what's it will do? It will make this turn value as a 1. Turn value will be make this 1, and then what's it will do? It will check this while loop. Interested other is T. yes, interested other is T. Interested other means this interested 0. This is 0 is T. Interested 0 is already T because it is already inside this critical section. Okay, this is T already, and then it will check this turn equal process. Turn is currently you see this is 1. Also process is also 1. So this while loop is true. So it will execute this while loop. Okay, so even though process P0 is currently inside this critical section, process P1 cannot be entered this critical section. Okay, it will execute this while loop. Okay, until process P0 completes its critical section. Okay, let's check this process P0 is done, and it makes this turn interested 0 will be F. Interested 0 will be F. Okay, this time this will be the F. Now again P1 is scheduled. It will see this interested 0 is T. No, interested 0 is F currently. Then the process P1 can enter this critical section. Okay, so in this scenario we can see this mutual exclusion is guaranteed. Okay, mutual exclusion is granted by these algorithms. Okay, and next let's check this another condition. Another condition is progress is satisfied or not. Okay, progress is satisfied or not. Okay, previously if one process is not enter this critical sections, it shouldn't block this another process for entering the critical section. Okay, let's check how it works. Okay, let's see that process P0 is currently scheduled by the CPU, and no process is not interested in the critical section, so it will execute this line, and it makes turn value is also 0. Turn value is 0, and make this process interested as a T, and turn value is 0, and then in here actually it's got the preemption. Okay, in the preemption process P0. Okay, right, and then process P1 enter interest for enter this critical section. What it will do? It will execute this line. It will make this other is a 0. Interested T means that interested here. It will make this T. Okay, interested, and then it will make this turn value as a 1. Turn value will be the 1. Turn value 1, and then what it will do? If it is now it will execute this while loop. It will see this other is T. Okay, other is T. Interested. Okay, other is interested, and turn equal 1. Turn equal 1. So it will execute this while loop once. It will execute the while loop. Okay, no process is not enter this critical section, but it is execute this while loop now. Okay, let's check this while loop. Can it actually wait for indefinite time or not? Okay, then process P0 will be scheduled by the CPU. Process P0 will be scheduled by the CPU. Okay, P0 will be the scheduled by the CPU. Then what's it will do? P0 will again it will execute this line. It will check this other is T, but turn equal to process is not true because process P0 is 0. So process P0 can enter this critical section. Okay, enter this critical section, and it's complete this critical section. Make this turn equal F. This one F. Again process P1 will be this schedule. Now it will see this turn equal F. Okay, turn equal F. Okay, turn will be the F, and it process P1 can enter this critical section. Okay, enter this critical section. Okay, so it doesn't actually wait for indefinite numbers of time. So progress is satisfied in here. Okay, progress is satisfied in this situation. Okay, now progress is fine. Progress is good in here, but let's check this. Another property is called bounded waiting. Bounded waiting is satisfied or not? Okay, bounded waiting. To satisfy this bounded waiting, we need to go for one infinite while loop for this and for this all code. Okay, now let's check this. P0 is interest for entering the critical. P0 is scheduled by the CPU by the operating system, and turn is 0 in here. Turn is 0 in here. Okay, 0 both are F. Okay, turn is 0. So P0 is scheduled by the CPU. So it makes everything. It makes shows here is F T interest is T, and then turn equal to 0 is fine, and then it is execute this one. So other should be 1 is false in here. So it can process P0 can enter this critical section. Now let's actually schedule another process P1. P1 will execute this other equal to 0 when P1. Then interested 1 is true, shows is interested, and it will make this turn equal 1. And then turn equal to 1, and then it will execute this while loop. It is see this other is false, so other is true, and turn equal to process is 1 is fine, so it will execute this while loop. Okay, let's take this P0 is currently completes its execution and makes its interest as an F. Interest is an F. Let's take this now. Process P1 again can enter this critical section. Sorry, again process P0 can enter this critical section or not by waiting the process P1. By waiting this process P1. Okay, P1 shows is interested. Now let's check this again. P0 is scheduled by the CPU. It completes its execution in here. Other and interested make it in true, and then it will make this turn as a again 0. Turn make it 0, and while other is interest, other is means is 1 is interested, and turn equal to process. Turn equal to process means this process. Okay, this one. Okay, this one 0. So it will execute this while loop. Okay, P0 can again enter this critical section. Okay, because it's modify this turn value is 0, and also other is also interested. Okay, so again process P1 is scheduled by the CPU. It will check this other is true. It is true. Other is true. Process P0 also interested, but turn equal to process. This condition turn equal to process means that in P1 turn process equal to 1, but here turn value is 0. Okay, this condition will be the false. So process P1 can be enter this critical section. Okay, so process P0 cannot wait the process P1 for an indefinite number of time. Okay, so in this process or in this mechanism, we can say that this bounded waiting is also satisfied. Okay, bounded waiting is also satisfied. Mutual exclusion satisfied. Progress is also granted. Okay, so it satisfies all of these properties. It is Peterson method. Okay, Peterson method. So some properties of this method. This process actually shows that in this process mutual exclusion is granted, and progress is also granted. Bounded waiting is also granted. Okay. Advantage is that it's granted all properties for synchronization methods. Also, there is no hardware support is required. Okay. Also, it implemented it in user mode as well. There is no special command is required for implementing this mechanism. Okay. Okay. Also, limitation is that it is also two-process solution. You cannot use for this method for multi-process solutions. Also, it is also busy waiting solution. Okay, here your process needs to execute this this while loop. Okay, this busy while loop. Okay, even though unnecessary while loop. Okay, so it is busy waiting solutions. It is busy waiting solution. Also, it is two-process solution. Okay, this is the problem for Peterson method. Okay, so today we learn three methods: strict alternation method, interested variables, and Peterson methods. Okay, for busy waiting solution, Peterson method is the best solution because it satisfies all of these three properties for synchronization mechanism. Okay, okay. So do you have any questions or comments so far? Today we learn total three algorithms. Okay. Okay, if not, today we can stop in here. In our next class, we'll learn the non-busy waiting solution. Okay, non-busy waiting synchronization mechanisms. Okay, we'll check this non-busy synchronization mechanisms, and also in your next I think next Thursday you have second midterm. Okay, second midterm. Please keep in mind. Okay, it will be a module 4 only. Okay. Okay, thank you everybody, and see you next class, and have a good weekend. Okay, bye bye.